The infrared spectrum of an organic compound is shown. So you're going to need to find table A on your data booklet. Remembering that the spectrum, the peaks below 1500, this kind of region, this is the fingerprint region, and so we're not going to be identifying peaks in this region using our data sheet. We're going to be identifying the ones to the left of that. So here we've got this smooth absorption that is between 3200-ish and 3500. We go to the data sheet. This is OH alcohol. It's not broad enough to be a carboxylic acid. A carboxylic acid would look much more like this, slightly over to the right, kind of absorbs this CH peak into the side of it. This is our CH peak here at around 3000, and here we've got a C double bond O. So by having a C double bond O and an OH, you're tempted to think it's a carboxylic acid, but this peak here is characteristic. It looks like a finger of an OH in alcohol. This peak here that's OH in carboxylic acid that I've drawn at the side, this I always think looks a bit more like an upside down mountain, and that's what tells me I've got a carboxylic acid. We definitely haven't got a carboxylic acid, so we're going to cross out ethanoic acid. Hydroxy is a word for an OH. One is a word for a C double bond O. Now that looks like the things we've got, so I'm going to select that, but I'm just going to double check. This is just an OH, and this is a double bond O and an OH. Now they've put that one in there because the alkene peak does come quite close to this C double bond O peak, but the alkene peak 1620 would be around about here, probably quite a lot smaller as well than a C double bond O peak. So that's why that one's being put in, to try to catch you out a little bit. So 4-hydroxybutanone is the correct answer.